So now, stability, let me just first of all quickly read the formality stuff over here. The position of center of gravity of an object affects whether it is stable or not when it is tilted, right? So this is an important in the design of such things as tall vehicles, which tend to overturn when rounding a corner, racing cars, reading lamps, even drinking glasses, right? Everything which basically is designed by a mechanical engineer in the physical world, in this earth, right? He takes care of stability, right? Because imagine a bus, right? Imagine a bus. Let's say these are the wheels of the bus, right? And again, these are the windows, okay? And this is the tailpipe. Okay, and these are smoke coming out of the bus. Okay, and imagine if the bus is basically taking a turn, right? And the road is basically tilted, right? Like this. It is tilted at a particular angle of 45 degrees, right? Let's say, and if it is not stable enough, okay, let's say the bus comes over here. The bus comes over here, right? And it is not stable enough, okay? It will basically topple down, right? We'll show it using a 3D picture, right? Okay, imagine okay, we just basically need stability so that the car does not topple over, right? Okay, what does topple means here? It does not. Let's say this is a car from the top, from the back side. Okay, and this is the wheel one. This is the wheel two, right? This is from the back side, right? So I'm viewing the car from here, right? So what I mean is this, okay? If it is taking a turn, okay, if it is not stable enough, this would topple down, okay, like this. If it is not stable, right? So now this is an experiment over here, which I want you to see and analyze. Okay. So can anyone explain कि is it going to fall down in picture A or picture B? The object is going to fall down at position at scenario A or at scenario B.
In scenario A, the object will fall down.
Hmm. Okay. So because this, let's say we had a case before this also. Let's say case C. Okay. If I extend this further, so imagine this was standing straight, right? Let me just choose the same color. Imagine it was standing straight, right? And let me choose this option into shape. Okay, imagine it was standing straight, right? Oh my god, that's a good rectangle. Use this tool further, right? Yeah. Okay. So this is scenario C when it was just stationary, right? And we were not playing with this object. Okay. So it is stationary and it is pretty much stable, right? So now again, for the love of physics, I am doing experiments, right? I'm doing experiments with it to just basically check its stability, right? So what is stability? So basically we try to topple the object by certain angles, theta, right? And we find what is the angle after which it basically topples down, right? So over here, theta is 0 because it is not inclined right now. Let me just turn off this option of creating shapes. Okay, delete it then. So I want to basically just this is theta 0, right? Which is not toppling right now. So I begin to apply a force in this direction, right? Now at scenario B, I have it at this particular scenario, right? So this is the center of mass over here, and the center of gravity is also passing through this. That is vertically downward, right? Okay. So this is basically, let's say, A, B, right? So I want this W to be between A and B, right? So this is point A, B. Okay, this is point A, B, right? So at picture B, at scenario B, again, my center of gravity, okay, is basically between A and B. So if I again apply a force till here and again leave it, so it will come back to its original shape. That is basically scenario C, right? Now at scenario A, what is happening? My W, my center of gravity is basically getting out of my A and B, right? So now this would not regain its original shape, right? So now this will basically, if I basically leave it, okay, so it will basically topple down, okay. So what is stability? So can you define stability now from this explanation? Can you explain stability now from what we have seen right now? Yes. Anyone? Okay, no one. So it is the ability of an object to regain its original position. Right? Does that make sense? So if I keep on disturbing this particular object, and if the center of gravity remains between A and B, so it will regain its original position, right? Which was this. Okay. But if it goes out of the boundaries A and B, it would topple down, right? So stability is defined as what? It is the ability of an object to regain its original position or maintain its original position after disturbance, right? Okay. So this is what is defined over here. An object topples or falls over when the vertical line, that is the center of gravity, it's basically falling outside its base, right? So you can see that this goes outside the base and it basically falls down, right? It fell down. And otherwise it remains stable, right? Till until and unless this vector, that is vector center of gravity, that is W, that is passing through the center gravity, is remaining between A and B, is going to basically again remain stable. Otherwise, it would basically lose its stability, right? Okay, so stability के लिए we need two conditions, right? We can increase stability of an object by two things. ठीक है? So let me just do an experiment with you guys for that. Imagine we have glasses, right? Imagine you're doing an experiment on a let's say on a table, right? And for a table, I need brown color. Where is brown? Where is brown? Brown is here. Imagine this is a table over here, right? And you have two types of glasses. You have glass A and you have glass B. So if I ask a question from you guys, this is glass A, this is glass B. Question is, which glass is more stable?
Class A.
Okay. So those who says glass A is more stable, raise your hand. Okay, Ruba says it, Hamza says it, Mashal says it. Otherwise, Ryan and Varda and May are saying, sir, glass B is more stable. Okay, so okay, Varda is now switched her pole. Ryan, why is glass B more stable?
Because sir, its center of gravity is lower.
Okay, is it lower?
Second item, why the answer A is correct.
So, Ruba,
Because the glass A has a wider base area and stability depends upon the base area. So glass A has a wider base area, so it will be more stable, whereas glass B has a smaller base area. That's why it's going to be less stable as compared to glass A.
okay, good. Yeah. So, everything comes for to the point of center of gravity, right? So, center of gravity can be affected. Yes, Hamza? Any question? Okay. So, everything comes to basically center of gravity, right? So, center of gravity is affected by two things. It is affected by either its base area, ठीक है, as you can see over here, and it should basically depend upon base area or center of gravity, right? Let me just flip it out. The stability over here. The stability is basically dependent upon two things: the base area and the position of center of gravity. Okay. So यहाँ पे we can decide using the idea of base area, right? As you all did. This is the base area of A, and this is the base area of class B, right? So you can just see this, right? This is area of A, and this is area of class B. Okay. Hello, Ryan. How are you? I can see you. Okay. So as Ruba said, he said area of A is basically greater than base area of basically. Let me just write completely that way you're not confused when you're reading the notes. Therefore, A is more stable, right? Okay. अब मुझे बताएं कि what about center of gravity? Can you locate center of gravity at glass A and glass B? Roughly, कहाँ पे होगी? Where would be the center of gravity of glass A? Roughly, it would be basically be around here, right? If it is symmetrical, a cylinder, it would be basically be here, right? But for glass B, it would be roughly around here, right? Because most of the mass of the glass B is at the top, right? So it would have a center of gravity which is greater than, basically higher than the glass of A, right? So the lower the center of gravity, the more stable it is, right? So you can also compare it from center of gravity point of view, right? So you can say कि center of gravity point of glass A is lower than the center of gravity of glass B. Therefore, it is basically A is more stable than. And you can do it experimentally, right? If you have these two sort of glasses in your homes, you can try to basically topple them and topple them by a force. And you can note ke after what point they are falling down, right? So you would see that glass A can basically remain stable after a great change of angle, right? However, glass B would fell down before glass A basically falls down, right? So therefore, A is more stable. These are all practical stuff which you can do at your homes, right? So does this make sense? If yes, then give me a thumbs up. It makes sense. So Ruba, Ryan, May, everyone. But so again, for increasing stability, it comes in your MCQs and your theory. You can just lower the center of gravity, or you can increase the area of its base height. Either way would increase the stability, right? Okay, so now this is on this particular diagram you can see this there is basically a truck, fire truck, right? There is a fire truck over here, okay, and they are basically lifting it by a particular angle, okay, that is theta, and they are checking basically trying to find its basically its stability point, okay, after which angle it topples down and also its center of gravity, right? So if they can find, this is an experiment which you can read further in your book. So there is much this is not so much important. Just imagine that they're trying to topple it down and they're trying to find the particular angle after which it basically fell down, right? So similarly, the coaches, the buses, every vehicle which is designed, they are basically checked for its stability, right? Because they move around roads which are tilted, right? They move around hills, they move around mountainous regions which have roads which are tilted, right? So they and for basically for passengers, for basically simulating that they are passengers inside the coach, they have put bags of sand, right? Just to assume that there are people inside this coach, and they're tilting it by a particular angle, which you can see. This is the angle by which it is being tilted, right? So they're trying to find its stability. Okay, let's say designer said okay, the angle at which it can regain its stability is let's say 24 degrees. So it can go over roads which are basically like this, right? Which have an deviation of tiltation of 24 degrees, this bus would not topple down. Otherwise, if it exceeds 24 degrees, it would basically topple down and it would basically cause an accident, right? That is why they're pretty rigorously checked before basically it is uh, purchased by the manufacturer by the consumers. Okay.
Yes.
Okay. Good. So just last ending points for the chapter, then we move towards doing question answers, right? This is basically an application of stability, right? Okay, how can you create, how can you basically alter stability to make objects stable, right? And they are playing with the idea of stability to create toys also, right? So have anyone played with this toy? किसी ने बनाया ये वाला toy? So basically you have a container. This is a container over here, can, ठीक है? And you take a needle, right? So needle पे you basically put a needle through the cork, ठीक है? A wooden, you can say, cap, right? And then you have two basically forks over here, right? So you stick, you basically do what? You put the fork like this, ठीक है? And you put this particular part such that this particular needle becomes stationary, right? So they are basically balancing this particular thin needle on a piece of on a can using idea of stability, right? So they have added more supporting parts, right? Which basically does what? It balances out this center of gravity point, and this, let's say, this is the center of gravity of the needle and the cork. So it basically passes exactly through the center of this, like this, right? So this is W, which basically makes it stable. Does that make sense? Okay, how are they playing with the stability idea?
Yes.
So they make sure that the W is inclined, is basically inclined with the needle, right? If it falls out of the needle will fall down. Does that make sense? Yes, if yes, thumbs up.
Yes.
I cannot hear you, Hamza. Can write in the chat. Yeah, does it make sense? So you
Sir,
basically,
can you explain this once again?
want, okay, ये कहाँ हो गया? कहाँ गया? You basically want this to be done. एक minute, let me zoom out. You want to basically do what? You want to make sure कि for stability, हमने देखा था ना कि अगर let's say if you have a can, right? And this is point A, this is point B. So your center of gravity vector should pass between these two, right? It should stay between these two boundaries, right? Similarly, if I zoom in further to this particular section, I would see it sort of this side, right? If I zoom in further
Yes.
to this point, I will see okay, this is a cross section, right? Which I will see. So I want this W to be small, to be between these two small boundaries, A and B. If I just label over here, this is A, this is B, right? So I want them between these two. So I'm using forks over here to balance it out to find a point such that basically becomes, it stays between point A and point B so that it basically becomes stable.
Okay.
Does that make sense? Okay.
Yes.
Okay. So if it makes sense now, give me a thumbs up. Okay, it makes sense to me. Mashal. Further. Okay, good. So now, similarly, you might have seen these toys also, right? You might have these toys, your cousins playing with it, or your little, uh, you can say, sisters, brothers playing with these toys, right? So what do they have? If I just explain this parrot over here, this parrot is basically made up of wood, and it has a very long tail, right? So they put a bulldog clip over here. So what happens basically is that, okay, they have lowered down the center of gravity, right? So they basically bring the center of gravity lower. Okay, so this is the center of gravity which basically gets lower after putting this weight on this particular toy. So which basically makes it more stable. And this parrot, let's say this was the center of mass, right? This was the center of mass, and this basically makes sure okay, this vector passes through the center of gravity, right? So it basically makes sure okay, it is balanced out, right? Similarly for this toy also over here. Okay. And has anyone played with this toy, sort of toy, in any party or carnival or any, let's say, any instance in their lifetime? You might have played with this toy. You can punch it, you can kick it. It again basically stands up. Has anyone played with this? If yes, give me a let's say a raise of hands. Ryan has played with it. Maeve also, right? So how do they design it? Okay, so we have also Varda with Hamza also. Okay, so how do they design it is as follows. They basically the base, right? The base of this toy is pretty heavy, right? So if you try to punch at the base, your toe, your thumb's toe would basically crush out, right? Because it's usually pretty heavy, right? It's usually made up of heavy rubber. So the most of the mass of the toy is at the bottom, right? So it is pretty mass dense, right? So what happens? And this is basically made up of plastic. Okay, it's pretty. It is basically used of plastic, and it contains air inside it, right? So if you kick it or if you punch it, okay, it goes over here. Since this is curved, right? It makes sure it comes back again, right? So this curved path, which is heavily dense with the mass, basically has lowered the center of gravity to this point, right? Which made sure it would not fall down, right? So this is the sort of center of gravity, and this is point A and this is point B, right? So it always stays between these points, therefore it is able to regain its original position, right? Does that make sense? If yes, thumbs up.